Hi, I'm Aranjan Kumar, Mathematical Mind online classes, and today I have I discuss a rational function. Okay, so what is the rational function? So, so first of all, discuss about the rational number. Okay, rational number, rational rational number. What is the rational number? Rational number, the form of the form of p over q, where q is not equals to 0 is called rational number. Okay, for example, negative 2 over 3, negative 7 over 8, 1 over 2, 5, and so many examples of a rational number. Same thing we have discussed in rational function. Rational function. So what is a rational function? A function f is a rational function if fx is equals to gx over hx, where gx and hx are polynomial and hx is not equals to 0 is called rational function. So here we so the form of gx over hx and gx and hx are the polynomial, and hx is not equals to 0. So this is a definition of the rational function, and now we have defined what is the domain of a rational function. So of rational function domain of rational function set of the consist of the domain consist of all real number all real numbers all real numbers except the zeros of the denominator hx. So here domain of zeros of the denominator of hx. So rational, do you know about the examples? So these are the many examples of rational function 1 over x minus 2. So what is here? This is the example of x minus 2 where where x is not equals to 2, right? Means that what is the domain of this function? Domain set of all real numbers except 2 x is equals to 2, right? Now, and their graph is, first we draw the graph, look like this: x, x dash, y, and y dash, right? Here is y dash. So what is the except here? So first we draw x is equals to 2. So here if I draw x is equals to 2, then the graph is move, look like this. Okay, so this is the graph of x minus 2. Okay, so what is this here? This is the asymptote. Okay, so this is also known as the vertical asymptote, and x is equals to 2, then because the x not lies of x is not equals to 2, that means the graph is fine on this. Okay, I discuss here, if I write next example, fx is equals to 1 over x, where x is not equals to 0. So what is the graph of this function? So graph is, first we draw here, this is also the part of the rational function, x, and here y and y dash. So at x is equals to 0, the graph is does not lies at the x is equals to 0 except 0. So the graph is look like this is the hyperbola, and this is the here. So graph of fx is equals to 1 over x, and domain of this function is x is not equals to 0, means all real numbers except at x is equals to 0. This is the another example of a rational function. So I give you another example here. If I take gx is equals to 5x over x square minus 9. So how can find the domain and of this function? So here, first of all, x is not, domain of this function is, all real numbers, except x is equals to plus minus 3. So this is the also uh, example of rational function and their uh, domain. Okay, my question is, how can find the range of the given function? So if I take fx is equals to y is equals to 1 over x minus 2, so x minus 2 is equals to 1 over y, and therefore x is equals to 1 over y plus 2. That means y is not equals to 0, means set of all real numbers, means that all real numbers except x, y is equals to 0. And we also known as, if you written in the sense of function, fx is equals to 1 over x plus 2. That is the also part of this given function. So set all real numbers except x not equals to, except x is equals to 0. This is the also example of a rational function. Now I discuss here how can the x approaches where a is any real number. If I say, if a is any real number, any a is any real number, is any real number. Now, sorry for that trouble of the internet work. So here, if a is any real number, now this is the approaches of a, right? X approaches, that means a is any real number, and x approaches to x approaches to a, means there's the two parts of a, left and right, left and right. So if x approaches to negative, x approaches to a minus, means that x approaches a from left, and x approaches to a plus, means that x approaches a from right. Got it? So if x approaches to a minus, means that fx approaches to infinity. So fx approaches to infinity means that fx increase with bond. Okay, and fx approaches to negative infinity means fx decrease with unbound. Okay, without bound, right? Without bound. Okay, so how can approach fx? If I say fx goes to infinity as x goes to a minus, so if you draw here, this is x, and here one is x dash, y and y dash. So at x is equals to a, if I say x is equals to a, you draw here dotted lines, imaginary lines, and you draw here look like this. That means the approaches x is equals to a from left, so that is the left side. And the same thing, if I fx approaches x, x dash, y and y dash, so if I draw here, if I do look like at x is equals to a, then if I draw look like this, that means y is equals to fx. Okay, here fx approaches to infinity, fx goes to infinity as x goes to a plus. That is, here f is left side, so a minus. Okay, and that one is, that part is fx goes to infinity and a goes to right side, a positive. So if I say the graph of right side, and that, and here graph is from left side, so that is fx approaches to infinity, and x goes to left side, a minus, and fx goes to infinity from right side. So we have discussed, if I say fx goes to a negative infinity as f approaches to a minus, that is the decreasing. Okay, so we say, if I draw the graph here, x and x dash, and say y and y dash, so if I take graph is approached like this, and you draw it here, x approaches to x tending to a, right? That is the a minus. Okay, and there, here also, if you draw y and here y dash. Okay, now if you draw here, look like this: x dash x y and y dash. If you draw this line and the graph plotted look like this: y is equals to fx. So infinity symbol, uh, the symbol the symbol infinity and minus infinity do not represent numbers. Okay, they simply they simply 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 specify certain types of behavior of certain types of behavior of function and variables. Okay, so this is the basic concept of the rational function and their graph. So today we have discussed look like this. So next class we have discussed approach, vertical asymptote and horizontal asymptote, and how can find the vertical and horizontal asymptote and their domain and range.